so you want x is equal to what? T. Sorry, there's t in this instead. You're absolutely right. So t is equal to secant theta. Nice. So you end up with, what do you end up with? Then you go from 2.
Root 2 to 2.
Root 2 to 2. Is it root 2 to 2?
Yes.
Still root 2 to 2?
As long as you keep t.
Ah, we have until we change it. You're absolutely sure. Okay, so then it's 1 over what?
1 over
Secant cube theta times secant, I know, secant squared theta minus 1. And what is secant squared minus, and dt, thank you. And what is secant squared minus 1? Tan squared, so then you get the square root, so you end up with root 2, 1 over secant cube theta times tan theta times dt. So now what do you need to do? Translate things around, right? So this is quasi-okay, so we know that we said t is equal to what? Secant theta, so we know that dt is equal to, sorry.
Oh wait, secant theta. Secant tan.
Thank you. Secant theta, tan theta, d theta, so d, you substitute that back in and you get a nice cancellation, right? But we also now know that we got to be careful of our limits here. Just I'm going to put some highlights around them just so we don't forget what's going on here. So end up with 1 over secant cubed theta tangent theta times secant theta tan theta d theta. Do we have some nice cancellations that happen? Tangents there, that's gone, and that's gone. So now we have the, yeah. What do we end up with? 1 over, see, yeah, 2 right there, secant squared theta d theta. What is 1 over secant? Cosine. So we have the integral of cosine squared d theta. Theta, thank you. That's nice. What are we missing? What haven't I not? Limits of integration. So how do we figure out what the limits of integration are going to be? Kind of invert them, worse, right? So it's pi over 3 and pi over. And usually, if we went back a few weeks, integrating cosine squared, that would be kind of a showstopper for us. We wouldn't really want to do that or know how to. Now we do, though, don't we? What is it? What do you have to do? What substitution do you do? Double angle. So what is it going to be? 1/2 of what? Hold on, one of you at a time. What is it, Thomas? Is it sine 2 theta plus 1? Who agrees with that? The back row agrees? You have the judges in the back are saying 10. Is that okay? I need your help with this. So now are we at a finishable state? Is that right? No?
No, that should be cosine.
Okay, so that's exactly why I asked you guys to back each other up. Okay, so fine. When you raise your hand to say he's correct, you probably meant to say, no, he's not correct. Okay, we got to work on those communication skills a little bit. So it's not sine 2 theta. What is it? Cosine 2 theta what? Plus 1. Thank you. It's cosine 2 theta plus 1. Cosine stays cosine. So is this nicely integrable? Yes. Do we have to do any more tricks is what I'm asking. No more tricks. We are now super, super happy. Yay. Now it's just evaluating the integral. So the fun begins. So the fun begins because you notice that x squared plus x minus 2 is equal to x plus 2 times. Okay, so I'm going to rewrite this integral slightly. I'm going to call it x plus 5 over x plus 2 times. Have I changed anything yet? No. So I'm going to keep this, I'll keep a nice boundary up here so it doesn't get in the way, but there's a boundary right here. We're not going to cross it. We're just doing some scratch work over to the side. We haven't changed anything. Do you agree? Okay, so here's the kind of the random deassociation or the random step. That's not really random, but the thing that is going to help us solve this problem, and it's this. I'll give you a smaller example first. Let's say I gave you 1 over 12, and you said that that's equal to 1 over 4 times 3. Is that true? Do you agree with that? That's equal to a over 4 plus b over 3. Some combination of the two. You know that one of them has to be negative, but some linear combination that is true. You can break it apart like that. Do you agree with that statement? If you wanted to figure that out, you would say that 1/12 is equal to a over 4 plus b over 3. And you'd have to do some manipulations. This isn't the best example, but it is a smaller example of what we are about to do. We're not going to do this. We're going to do something similar. Instead of 4 and 3, what do you see? You do, exactly. So you know that x plus 5 over x plus 2 times x minus 1 has to equal something a over x plus 2 plus something b over x minus 1. How do you go about finding what a and b are? How do you go about finding what a and b are? So how did you go about it when you were trying to solve this? What did you do? You tried to add the fractions together, right? So you know that it's a times x minus 1 plus b times x plus 2 all over x plus 2 times x minus 1, right? Okay, so you know that this has to be true, but if the denominators are true, it means the numerators have to be the same. So you know that x plus 5 has to equal a times x minus 1 plus b times x plus 2. And I'm going to help you out a little bit more here because I understand. I'm going to give you a quicker way. You ready? Want to see a magical thing? This relationship has to be true for all x values, correct?
Yeah.
Do you agree with that?
Yeah.
So choose an x value. Ready? I'm going to choose an x value. X value, I'm going to say x is 1. No, x is 1. That's better. Because then what happens? You get 6 is equal to b times 3. So what's b equal to? 2. And then I'm going to pull a random step out of thin air again. I'm going to say that, I don't know, how about x is equal to negative 2? In which case you get 3 is equal to a times negative 3. So a is equal to? Done. I'm giving you the quick way because this is called partial fraction decomposition. And this mechanism right here is something that we used to teach in Algebra 2 because it's an Algebra 2 topic. And when do you use it? Right now. For years, I didn't teach, for the first half of my career, I didn't teach BC calculus. So I'd always say, you're always going to use this in calculus, but I never actually got to teach it. So this is the first reason I'm really excited, because it's coming true! Okay, so now we know, now what do we know? We know that this integral is equal to negative 1 over x plus 2 plus what? 2 over x minus 1 dx. These are the same, right there. We haven't done anything. So now we have the negative the integral of 1 over x plus 2 dx plus 2 times the integral of 1 over x minus 1 dx. And what are those integrals equal to? Negative ln of x plus 2 plus 2 times ln of plus c. Check that out. Pretty cool, huh? I think it's pretty cool. Are you excited?
Yeah.
I'm excited. So you take your x minus 1, and then you write x cubed plus 0x squared plus x right there. That's nice. Sure. Leading over leading. You need to remember this phrase, leading over leading. That's the key phrase. The leading term first is x cubed, so do x cubed over the other leading. This never changes. That's always the leading term. X squared over x, x cubed over x is, and you write that right there. Same thing as division. Once you get that first one, you multiply right here. What's x squared times x? X cubed. X squared times negative x squared. Now what do? Just like long division, you subtract the whole thing. So what do you end up with?
You get 0 plus,
Yep.
0 plus
Yeah. X squared. And then what do you drop down? You drop down the x. Now what's the leading term? X squared. So now you have x squared over x. It's the same x in both of these bottom cases. You have this x, this all the same right there. So what do you end up with now? Just x. So you plug it right there. X times x squared again. You do both of those multiplications. Yeah, x times x. So you get x squared minus x, and you have to subtract. By far the most common mistake in polynomial long division is forgetting you're subtracting the whole thing. Not distributing, and it goes this vortex of not fun. Yeah, it does. Because it's really messy work, and if you mess it up in one place, it cascades down. So what are you left with? 2x. So now you have 2x over x is 2. So you end up with plus 2. Then you get 2x, and you drop down the 0. So you're right, that definitely helped. minus 2, subtract, and you're left with 2. Can you go any further?
Not exactly.
This is the, yeah, you don't do the process. So what did we just find out? We just found out this. X cubed plus x over x minus 1 is equal to x squared plus x plus 2 plus what? 2 over x minus 1. All we've done is we've rearranged. We haven't done any calculus. This is polynomial long division, something that we at least should teach in algebra 2. I hope we do. So we end up with this integral. The integral of x squared plus x plus 2 plus 2 over x minus 1 dx. Can we integrate that? Yeah. 1/3 x cubed plus 1/2 x squared plus 2x plus 2 times ln of x minus 1 plus c. Done. All we did was rearrange. So we now have two, we're kind of remembering or maybe relearning 2 ways that you knew to rearrange rational functions. Rational functions are polynomial over a polynomial. Let's see how much fun we can have with it. So what was that first step? We had to rearrange, right? And I'm just going to let you do the grunt work for me. You know, it's x squared plus 2x minus 1 over what? X times x times x plus 2. Yep. Are we in agreement so far? What do we think, girls? Erica, sit up. Are we in agreement so far? Yeah? So now what are we looking for? We're looking to rearrange this, right? And did anybody figure out what it rearranges into? It's going to be 3 things. Something over x, something over x plus 2, and something over... Did anybody figure out what's the numerator for x? Anybody have it besides Andrew? Anybody? What'd you get, Thomas? We got 1/2. Good. What about x plus 2, Fawn? What'd you get? Nothing over x? Oh, okay. Anybody have the middle two? What'd you get? McFall, what'd you get for the x plus 2 one? Negative 1 over 10. Anybody get the last one? What'd you get, Thomas? 1 over 5. Who agrees with that? We're essentially home free at this point, because now what do you have? You have 1/2 of the integral of 1 over x dx minus 1 over 10 times the integral. Oh, it's not 1/10. Yeah, it is 1/10. What am I talking about? Yeah, 1/10 times the integral of 1 over x plus 2 plus 1/5 times the integral of dx in each case. Oh, d something I wrote there. I don't know what that is. Dx star. Yeah, you figure it out. Okay. So now what do you end up with? 1/2 of ln of x minus 1/10 of ln of 2 plus 1/5 of ln of 2x minus 1 plus c. What does this have to be? 1 over 10, yes, because what's on the inside there? Because of this thing, right?
Yeah.
Be careful. What's always in play? Chain rule is always around. Okay, so you're there, you're happy and nice about that. So what is it? What'd it say? So that's nice. Plus x minus what? Over. You got stuck there, right? You're like, man, we've learned so many tools, I don't know which one works. You keep on trying keys in the lock, it doesn't really work. Well, how about I do this for you? Does that help you at all?
Yeah,
Well, this is okay, and so is this, right? What about that one right there? This is the one where you're like, huh. Well, 1 plus x squared, it's something. We have the integral of 1 over x dx plus the integral of x over x squared plus 4 dx, which we're okay with. And then we have minus 1 over x squared plus 4 dx. Is that correct? Huh. Something interesting here. I don't know. We're okay. Is it okay if we just ignore these for now? Let's just ignore them. I'm really only interested in what's going on with that one, right? How about I do this? Oh, let's say minus, and we'll just keep, it's going to be minus there. We'll even ignore the negative for now. How about I do this? Can I do this? I don't know. Let's say the integral of, I don't know, 1 over, I don't know, 4 times, I don't know, x over 2 squared plus 1. Is that something? What's that? Is that okay? Did I change anything? Did I change anything? No, I have 1/4 times 1 over x over 2 squared plus 1 dx, right? What's that going to be? That's 1/4 times inverse tan of what? X over 2, but then what do you have to put on the outside? Times 2 to take care of the chain rule again, right? You're going to kick out a 1/2. So what do you end up with? 1/2 arctan of x over 2. You are absolutely correct that when you see this, you should think to yourself, arctan, where's, oh, there it is. You guys are clever enough and well-equipped enough to think, I can make that look like what I want it to look like. It's not quite there yet because of this 4. So factor it out. You just have to be very careful about the pieces. Don't get to the end and then forget. What do you think you've forgotten all the time? Like that, right?
Yeah.
If this was some sort of wicked hard multiple choice question, they would give you the option 1/4 and 1/2.
Yeah.
Absolutely. Be careful.